Hey guys, welcome back. In continuation to our last lecture, we would be talking about services and endpoint objects. So, as pods come and go, scaling up and down, failure, rolling updates, etc., the service dynamically updates its list of pods. It does this through a combination of the label selector and a construct called a endpoint object. Now each service that is created automatically gets an associated endpoint objects. This endpoint object is a dynamic list of all the pods that match the service label selector. Now Kubernetes is constantly evaluating the service label selector against the current list of pods in the cluster. Any new pods that match the selector get added to the endpoint object, and any pods that disappear gets removed. This ensures the service is kept up to date as pods come and go. The endpoint object has its own API endpoints that Kubernetes native apps can query for the latest list of matching pods. Non-native Kubernetes app can use the service virtual IP, which is VIP, which is also kept up to date. Now let's talk about accessing from inside the cluster. When we create a service object, Kubernetes automatically creates an internal DNS mapping for it. This maps the name of the service to a VIP. For example, if you create a service called Hellcat SVC, pods in the cluster will be able to resolve Hellcat SVC to the service VIP. Therefore, as long as you know the name of a service, you will be able to connect on it by a name. Okay, let's talk about accessing from outside the cluster. We can also use services to access pods from outside the cluster. We already know that every service gets a DNS name, virtual IP, and port. A services port is a cluster-wide, meaning it maps back to the service from every node in the cluster. We can use this port to connect to the service from outside of the cluster. Let's take an example. At the lowest level, we have nodes in the cluster hosting pods. Then we create a service and use label to associate it with pods. The service object has a reliable port mapped to every node in the cluster. The port that the service uses is the same on every node. This means the traffic from outside of the cluster can hit any node on that port and get through to the application pods. Now, in the figure which you see on the screen, this one shows an example where 3 pods are exposed by a service on port on every node in the cluster. In step 1, an external client hits node 2 on that port. In step 2, it is redirected to the service objects. This happens even though node 2 isn't running a pod from the service. Step number 3 shows that the service has an associated endpoint object with an always up-to-date list of pods matching the label selector. Now step number 4 shows the client being redirected to pod 1. The service could easily have directed the client to pod 2 or pod 3. In fact, future requests may go to other pods as the service load balances traffic between them. There are other options for accessing services from outside of the cluster, such as integrating with load balancer from your cloud provider. However, that starts getting platform specific. Implementation differences between Google and AWS, etc., and we are not discussing about those. Okay, let's talk a bit about service discovery. Now Kubernetes implements service discovery in couple of ways. Number 1, DNS preferred. Number 2, environment variables definitely not preferred. Now, DNS-based services discovery requires the DNS cluster add-on. If you followed the installation method, what we discussed in the earlier chapters or lectures, you already have this. The DNS add-on implements a pod-based DNS service in the cluster and configures or Kubernetes nodes to use it for DNS. The DNS adds on constantly watching the API server for new service and automatically registered them in DNS. The result in every service getting a DNS name that is resolvable across the entire cluster. Now the alternative way is through environment variables. Every pod also gets a set of environment variable that assist with the name resolution. This is a fallback in case you are not using DNS in your cluster. The problem with environment variable is that they are inserted into pods at creation time. This means that pods have no way of learning about how new objects added to the cluster after the pod itself is created. This is a major reason why DNS is a preferred method. Now, altogether, whatever we discussed in the past two lectures, let's summarize it. So services are all about providing a stable networking endpoint for pods. They also provide load balancing and a cluster-wide port that the service can be accessed on from outside of the cluster. We associate them with pods using labels and label selectors. So I think you well understood this. We are taking a pause here, and in the next lecture we will be talking a few things more about hands-on with the services and related things. So till then, thank you very much.